Good afternoon. Today we're going to talk about the state of the union and disaster recovery. Rafa, you got a special treat with two Rafas, right?
Two Rafa. Yeah, my name is Raffaele Spazzoli. I work at Red Hat in a consulting capacity. I'm an architect, especially focused on OpenShift. And for the CNCF, I work in the operational resilience tag. Previously, I was in the storage tag.
Very good. I am the Brazilian Rafa. Or the Italian Rafa. I'm a principal engineer for StormForge by CloudBolt. And I am a tag co-chair for Operation Resilience. And part of this talk, bring a little bit, some of my experience as a former Valero contributor for this space. Right, very quick. What's the agenda for today? We're going to talk about the fundamentals of disaster recovery. We're going to talk about the approaches, some of the capabilities required for each approach, most of the approaches. And then we're going to talk about each approach in terms of requirements and where they are in the perspective of the CNCF landscape. All right, the first disclaimer is DR is a discipline to restore the application. We are bringing the perspective, it's part of the application. The cluster is just a mean for the end of an application. So you can argue the disaster recovery is on the platform engineering, but we are bringing here the point that the developers, the architects of the application should care about the DR. There are two very key metrics or concepts. One is RTO, recovery time objective. It's how long the app, notice that we're going to use the word app, not the cluster, how much the app can tolerate downtime, how long it takes for the recovery to happen. The second key concept, RPO, recovery point objective, is how much data the application can lose. So those are the two concepts, key concepts on any DR conversation. And here is a graphic to explain this, because I was talking to Raffaele. I'm not that smart. I want to see in the nice picture. So you have the disaster right in the middle. So basically before in seconds, minutes, and hours is what is the time of the last data available. And after the disaster, how much you're going to need for the application to recover. So those two dimensions, the closer to zero to the disaster, more money will be the solution for it. And the money means any cost. Could be cognitive cost, could be cloud cost, could be etc. So these low SLOs, you can take minutes, hours, and days on both dimensions. Medium SLO, seconds to minutes, and fast was under seconds. So, and another key point is, in this world, one size does not fit all. You can have multiple options for each application. Different applications require different solutions. So one approach is the backup restore. You have your active cluster, then you take a backup, put it in a different location, could be an S3 bucket, whatever it is. Something happens, then you restore the backup. In that case, of course, is active passive, right? You need to have an event to trigger the other site. The RPO is the time, the last time you have data. It depends on how long you take the backup. And RTO can take hours depending on the size of the backup. The second approach is volume replication. In that case, it's up to the volume subsystem to do the replication of data. And depends, could be asynchronous or synchronous. If you have asynchronous data, RPO, when you write, there's no guarantee. It can take, the point in time can be milliseconds, could be seconds. Of course, depends on the technology of the volume. RTO minutes, for synchronous The RPO is 0 because when you write, you confirm that's right, and then the application moves on. The third approach is what we call transaction replication. In that case, the application has some mechanism to replicate the transaction over a messaging bus, a middleware somewhere, and then of course each part of the application has its own disk and writes on that disk. RPO is 0, RTO minutes. And then the fourth approach, where we have really, really distributed stateful workloads. In that case, you have your application, in that case, the database cluster that makes all the strong consistency, and that you have a truly active technology. Rafa, want to go?
Thank you, Rafa. Okay, so and now we have seen the 4 archetypes. Oh, now you can build a disaster recovery strategy. Of course, the world is much more complicated than these pictures, because customers have thousands of applications, each of which can use different and a different archetype, and then there are dependencies between these applications. So in the real world, it's much more complicated, but we have to make this subject tractable, right? So that's how we simplified. Now, for the rest of the session, we're going to look at what are the requirements to implement these approaches, and where are we in cloud native with those requirements, right? What is the status? That's why we call the talk State of the Unions, right? So as a union of projects, so it's a talk to the maintainers, as a union of projects here, where are we with supporting these capabilities? So before we get there, let's see that putting these archetypes all on the same chart, we can see that the first 2 are very much storage oriented, right? They require capabilities from storage. One is backup and restore, the other is volume replication. The next 2 on the right are more networking oriented, and they both require some sort of east-west communication, right? If you have failure domains that are Kubernetes clusters, these capabilities require, these architectures require an east-west communication capability between the clusters, so some sort of network tunnel between the SDNs of the clusters, okay? And then we have, there's always the global load balancer in front. That's needed everywhere to decide whether you go to the active cluster or to the passive cluster, or if you are active, which cluster you go to. So I put all of this capability in a slide, summarizing them, right? So backup, restore, global load balancer, and you can see them here. I'm not going to repeat myself. But now we're going to analyze each of them and try to understand where we are. If our intention is to use CNCF projects on top of, let's say, a Kubernetes deployment, right, to enable these capabilities. Let's say we're building a platform, we want tenants to come and use our platform, we want to give them these capabilities. Where are we with this? Where are we in terms of technology? Can we actually implement these capabilities? So first, global load balancer, it's needed everywhere, right? So a good global load balancer, first of all, global load balancer already exists everywhere, right? Because every customer have 2 or 3 data centers, or they have regions in the cloud, so they will have global load balancer. What we need here is something that configures the global load balancer automatically based on what's happening in the cluster, right? Including if a disaster is happening, right? So what do we need from this load balancer and this operator? We need the ability to configure health checks so that we can know if the application is failing, we switch the traffic. And we need some sort of load balancing policies to describe whether the application needs to be active-passive or active-active with weights, or maybe some geographical type of reasoning, right? And there are 2 ways to build global load balancers. One is DNS-based, where the DNS, you resolve the DNS, and the DNS decides if you go left or right, let's say. And then there is Anycast base, where you send a packet to an IP, and then a router decides if you go left or right? So Anycast can be IPv4 and IPv6. Of course, Anycast is better in terms of performance. There are no caches involved. It's much better, right? But both could work for our disaster recovery strategy. Now, where are we with these capabilities? We have KIGB. We have a maintainer here that can do this for DNS, type of load balancer. Unfortunately, we don't have, that I'm aware of, even whether we talk about inside or outside CNCF, we don't have projects that can do IPv4 or IPv6 based global load balancing. It would be nice to have. I think Metal LB can get close to that with the BGP implementation, configuration profile if you do that. But you still have to force the two clusters to publish the same IP. So it's a very unnatural thing to do. You usually just create a service and get the IP assigned. But if you have two services that represent, two deployments that represent the same services, you would have to force them to use the same IP. So Metal LB can get close to it, but we're not there yet. So call to action here is, let's have more projects like KIGB, maybe even targeting the Anycast space, okay? Now, east-west network path. This is a place that has not been very much standardized, I think, in terms of the CNI specification, right, or other standardizations, except for the MCS, the multi-cluster API, which is a way to say that a service exists also in another cluster, but it doesn't tell you how the transport is configured, right? It doesn't take care of that. So a lot of projects, a lot of CNI will perhaps have that capability. No, I want to say a lot, but some CNIs have that capability, like Cilium or Calico. They have that capability out of the box. But it's not a standard configuration that you can just request in Kubernetes. You would have to, you are dependent from the CNI that you pick. So again, perhaps here we could think about how to say, I want to essentially to build a connection between the two SDN, like some sort of routing path, without having to know the exact CNI implementation. Okay. However, it's not that bad here. There are a lot of solutions in this space. The next one, backup and restore. So where are we with this capability? There is a lot of choice. There are a lot of products, both in the CNCF and outside. The products outside of the CNCF are mostly vendors that have been in this space for a long time, and they have acquired some cloud-native capabilities. But there are also projects here in the CNCF.
Some are open source, but not CNCF, which is Valero.
Yeah, some are open source, but not CNCF. They could become a CNCF project. Where are we with this, though? There is a capability that is needed, change block tracking, which is needed to make to enable making backup at scale. Okay, because if you think about how a backup works, normally you take a snapshot and then you copy the snapshot somewhere in a safe location. But if you have thousands of workloads in a cluster and you take a backup every day, then you have to move all of that data every day and essentially clog the network. So with change block tracking, you can move only the differential blocks from the last snapshot that you took, right? So the status of this change block tracking capability is that it is in the CSI specification finally, and Shin, I think, worked a lot to make that happen. but it's still not very widely adopted by the CSI implementers. So here, the call to action is, please adopt this capability in the CSI by all the vendors. Then the backup and restore products can make use of this capability, and then we enable backup and restore at scale. Okay, next one, volume replication. Okay, so where are we with volume replication? This is highly, highly requested this day, because as you know, there is an influx of new workloads. As you probably know, there is an influx of new workloads in Kubernetes with KubeVirt. A lot of people want to move their virtual machines inside of Kubernetes. And virtual machines, if you want to do a disaster recovery strategy, you're going to disaster recover the entire virtual machine. So you need to have a replica of the disk somewhere, of the virtual machine somewhere else. People are not at this point trying to disaster recover the application that runs in the virtual machine. You disaster recover the entire virtual machine. And you could use a storage-oriented approach, so backup and restore or volume replication. But the reality is for the SLO that they want to hit, you need volume replication. And when these things happen, they happen with storage arrays, right? So things like Pure, or Dell, or NetApp, or Hitachi, this kind of technology. So the challenge here is, how do we configure that a volume that is being used by a virtual machine is being replicated from here to that array, from this array here to that array over there? At the moment, there is no CSI specification to do that. CSI would be the right place to have that capability, right? Because the storage, it would create a layer of abstraction between what is the actual vendor implementation and above. But at the moment, there is no CSI implementation. So what's happening, and I follow this every day, what's happening is that every vendor is creating a CSI proprietary extension to configure volume replication. And it's very confusing. They're all different. So it's impossible today to create a storage agnostic orchestration, right? A DR orchestration. The orchestration is something that looks like here, this picture here, right? Where you fail over, so you lose a disk, you fail over on the other side, and then you restore replication in the other direction, because now when you recover the other side has lost transactions, and then you fail back again if you go back to the initial state, right? So the status is we don't have a standard, and therefore we cannot have a storage agnostic disaster recovery orchestration. So nobody in this space is building a product to do disaster recovery, right? Until we created this standard. So here, the call to action for me is, storage vendor, please come together and decide for a standard. It's not that hard. After all, conceptually, you just have to say, this volume here, I want it to be replicated over there. And then we can build some disaster recovery products. Okay. Next one is middleware with primary and secondary, so master slave or primary and secondary type of middleware. This is most of the incumbent databases are like that. So MySQL, Postgres, I think SQL Server also. They all have operators where you can say, okay, this is my primary, and in this other cluster, I'm deploying my secondary. If you have an east-west tunnel, they establish a synchronous replication, right? Streaming replication, sometimes it's called. I gave a demo for a storage vendor, for a database vendor just last week, where we set this up. But there is no way to, all of these operators have a different way of defining what is the active
syntax kind of thing.
Yeah, different syntax to say which is the active and which is the passive. Yeah. It would be nice, like, because I have customers that are trying to set up database farms. I think this is becoming more and more common, where they start to realize that they've been running database farm in virtualization, but really nothing is stopping them from having database farms in containers, right? So if you have 1,000 databases in a cluster and the cluster fails, and they are different databases, right? It would be nice to have a single instruction to say, okay, everybody now disaster recovery, or change the active one to the other place. So here, this is, I'm imagining a little bit how you could do this, but it would be nice to have a sub-resource, right? Like a replicas, for example, is a sub-resource, right? So you could have a sub-resource that just describe the DR status. So am I active or am I passive? And then you could have operators that just understand the sub-resource. The rest of the resource could be anything, but everybody in this space, they conform to this sub-resource, and then you can write operators that can do disaster recovery for all kinds of databases. So here, just if you guys want to contribute in this space, I think defining the sub-resource and then some sort of middleware agnostic orchestrator, it would be a great contribution. On distributed workloads, this is where this is the nirvana, right? If you can get, you could have 3 failure domains and spread your workloads, databases, or caches, or messaging, whatever you have, right, across multiple failure domains. Then, when you lose one of these domains, typically this kind of software, they just reorganize themselves. You don't have to do anything, right? There is no disaster recovery procedure. It's more like an HA event. So here, there's really nothing that we have to contribute. They just work well. It's just that for some reason they're still not widely adopted. Right? We need to push this project a little bit more. We need to increase the awareness about these projects. You want to do this?
Yeah, very good. The call to action here. Always remember that we are part of the tag Operation Resiliency. We're trying to bring some of the business continuity is part of that tag, and that's we want to spread the message and recruit or be happy to coordinate events or efforts. So one big message is DR, one size does not fit all. Consider to contribute on those CNCF projects that Rafa just spoke. We still need like an operator to automatically configure the global load balancers. You have the global load balancers, but you still have almost like a management layer to make that happen. We spoke about DNS and cast. A CSI extension for volume replication is almost for grabs. The opportunity for anyone to go and make this agnostically that connects to the other bullet point. TIKV, it's a CNCF project. When I started to do some research, I found that it's only used in China, and we need more traction, right? As a CNCF project, we don't want to see this isolated in a certain geographic. And if you're considered to look into or want to help, please reach out to us. We're more than happy as a tag to organize this and join our tag. There's the mail list, Slack, etc. And we are very approachable, and we just want to get everyone on board on DR.
Thank you. We just got the 10 minutes signal. So this is a good time for questions, if you have any. Yeah, I will bring you the mic. Hi, by the way.
Yeah, thanks. I have a questions about disaster recovery and the initiative of volume replication. What do you think about volume snapshot and how maybe started with that? Because you can use this volume snapshot that already exists in Kubernetes. So I don't know if you explore this to try to push.
So this is already exists. This already exists, and there are companies that do this strategy. today, you get you get an RPO of 15 minutes with volume snapshots, because the way it works is you take a snapshot, you bring the snapshot somewhere into the cloud, then you restore the snapshot, and now it's ready to go if somebody fails. But all of that, more or less, you can repeat that loop more or less every 15 minutes. And so this works for some companies, but for most companies that want to run virtual machines, this doesn't work.
Yeah, the closest that I got to this scenario is using Velero. There is a way, Velero relies on Restic as an agnostic layer for data, but it does not scale for every, you can't reach out minutes for this. It's really a backup restore by the end of the day. Restic works, you take the snapshot, it mounts and send over to the other Restic and then writes on a, it's too slow. Right, I think everybody understands what RPO and RTO is, right? Any other questions? All right.
Okay.
Thank you so much.
Thank you.